Hello there, this is Professor Eckhouse, and I'm going to talk today about an introduction to limits. Limits are the basis of everything basically that we do in calculus. So if you don't understand, make sure and ask for help. All right, so what I'm going to be doing is I'm going to do a little lecture, and then I'll insert a question, and then this time I'm actually going to have an example of the question after the question in the video, so there will be a place where I go over it. So if you really are struggling with that problem, just move on to the next video portion and you'll be able to see how to work it. If you didn't have any problems getting it right, you can skip that next portion after the question where I help you do it. Okay, so let's start with the motivation for this. What is the motivation for this? The following four graphs of functions indicate different behavior around the value of x equals 3. Okay, so x equals 3, we've got four different functions. We're looking at what's happening in each one. So if you look here, we just have a value on the curve. Nothing special going on. It just has a value of 3, 2, right? So x is 3, y is 2, no big deal, it's just a parabola. All right, in B, to the right, as you can see, that's a straight line with a hole in it. And if you remember our talk about rational functions, if you factored the top, you would see that there's an x minus 3, and this x minus 3 and the top x minus 3 would cancel. And because they cancel, there's a hole. Okay, so that creates a hole because they cancel. So if you look at the graph, you see that there's a hole there. So we're going to be talking about limits, which means what's happening as we approach that hole? What are we approaching? What are we getting closer and closer to in terms of y? We're getting closer and closer to 2, but we never actually get there. Okay, so that's the idea of a limit. We can't get there because it's not there. There's an open hole. All right, in C, we have something different happening. This is called, and let me go back up here and I will name this in writing. So that is a hole, okay? This next one is called a jump. These are all discontinuities, so this is a jump discontinuity. And in this case, f of 3 does not exist, just like up here. So if I asked you what f of 3 is right here, you would say it does not exist. In this case over here in A, you would say f of 3 is 2, right? F of 3 is 2. But if we come down here to C, we can see it also does not exist, just like in B. So we would say that f of 3, again, does not exist. It does not exist because this is a jump discontinuity. Okay, you can see the function is an absolute value function. Absolute value functions generally have jumps in them. All right, the next one, as you can see here in the function, we talked about this. This is a reciprocal squared function, which looks like that. It's been shifted over to the right 3. Okay, so hopefully you're at a point now where you can anticipate that by looking at the graph itself. At the function itself, what the graph was going to look like. Okay, so if not, just keep practicing those toolkit functions. Okay, so in this one, again, if we look at f of 3, we would say that it does not exist. So in B, it was a hole. In C is a jump. And in D, it is called an infinite discontinuity. Infinite discontinuity. Okay, because these things both of these go to infinity, but they never get to 3. They get closer and closer and closer and never get to 3. All right. So we're going to talk about the definition of a limit next here. So the definition of a limit, I am not going to read this to you. So pause the video for a moment and read through that and see if you can make sense of it. So what we say here with this symbol down below, this here, is, I'm going to say it in English, so you might want to write this down. The limit as x approaches a of the function f is equal to L. I'll say it one more time. The limit as x approaches a of the function f is equal to L. L is just some number. Okay, so in all of these, they are approaching x is approaching 3. So our example up here is that the limit as, all right, that's a little bit big, the limit as x approaches 3. That's what we would write for all of those up there. Okay, of the f of x, whatever it may be in each case, sometimes it's p of x, sometimes it's g of x, whatever the function is equal to some number, okay, or something. It might be infinity. So we're going to talk about this a lot for the next few days. All right, so next you have question 1. So the video is going to pause here and you should answer question 1, and then we'll go straight on to the next portion of the lecture. Okay, so next we're going to talk about evaluating limits from a table. All right, so if we are coming towards a number, so what are we going towards? Well, x is approaching, getting closer and closer to 1. So stop and think about that for just a second. Pause anytime you want to through this video. So we're at 0.9, and then we're at 0.99, and then 0.999. It's just going to go on until we're approaching, so we're approaching 1, okay, from the left. So what is f of x approaching? Okay, so what is f of x approaching? Think about what it's approaching. It's getting closer and closer to 2. So this is getting closer and closer to 1, while this gets closer and closer to 2. So how would we write that as a limit? And this is what's happening. We're coming in from the left, right here, getting closer and closer to 1, but we can't ever get there because it's not there, right? It's up here. So it's not, as we come along the line, we're approaching 1. Okay, we're approaching 1. So limits are asking what we're approaching. They're not asking what the value of the function is. So we are being asked to evaluate the limit as x approaches 1 of f of x. So on the table, it shows us x getting closer and closer to 1. It shows f of x getting closer and closer to 2. So the way we would write this is we would write the limit as x approaches 1. Well, which side are we approaching from that we've written here in the purple? We are approaching from the left. So I'm going to put a little line here that's a minus sign, and that means from the left. Very important that you know this notation, from the left. Of f of x, because this function is called f of x, equals, well, what are we getting closer and closer to? Well, we're getting closer and closer to the value 2. Okay, so it equals 2. The limit as x approaches 1 from the left of f of x, and I wrote that wrong, I apologize. It's going to jump all over the place here, but I'm going to take that, I'm going to scoot it up. The limit as x approaches 1 should be down below, written small. Okay, the limit as x approaches 1 from the left of f of x equals 2. All right, so now let's come in from the right. So we're coming in from the right, so this time we're going to come in from 2.001 and then 2.000001 and then a whole bunch more zeros. And so we're getting closer and closer and closer to the value of x equals 1. On this, we're getting closer and closer to 1. So x is 1.1, and that's 1.01 and 1.0001. It just gets closer and closer and closer to actually being 1. At the same time, we're getting closer and closer to 2. Again, coming from the left. So the way we're going to write this as a limit is limit as x approaches 1, you guessed it, from the right, we use a plus symbol. So we're going to say from the right is what that means. We're coming in from the right of f of x, again, equals 2. So if we come from the right on the graph, if we come from the left on the graph, what we are approaching is 2. So I want to make clear here, though, that this right here, I'm going to change the color here so it's very clear that I'm talking about something different. I'm talking about something different. So f of 1 equals 3. That's the actual value. If you plugged 1 into the function, you would get 3. But this is a removable discontinuity. Okay, so this one is called removable. removable discontinuity. And the function value is 3. But the limit, as x approaches from the left or the right, it's approaching 1. Okay? So let's talk about a one-sided limit. I'm not going to talk about this too much. I'm just going to let you look at this definition and notice what I just wrote is what this looks like right here. Okay, the limit as x approaches some number from the left is L, or you can come in from the right and you would write it like this. And I encourage you to stop the video for a moment and read those definitions and see if you can make sense of them in English. All right, so an example is if we evaluate the one-sided limit for the function in this question right here, in both cases, coming from the left or from the right, and this little minus sign right here should be up as a superscript. It just didn't show up that way. So in both cases, we say that we get, and this is important, we get 2 coming from the left, right? We got 2 right here coming from the left. And when we came from the right, we approached 2. Okay, so coming from the left or coming from the right, we approach 2. All right, what that means is, so we say, and this is important, so we say that the limit as x approaches 1 with no plus or minus sign, in other words, the actual limit of f of x is 2. Okay, so I'm going to make this really clear. Both of these must be the same in order for this to be true. Okay, in order for this right here to be true. Both coming from the left and coming from the right must be the same in order to be able to say that the limit as x approaches 1 equals 2. All right, so let's move on and look at another one similar to this. Actually, I think I jumped ahead of myself and I need to do one more page before I can go up and do question 2. So let's look at this. I put it in the wrong order. That's okay. We'll go back and look at it in a moment. So let's let f of x equal this function here. I'm guessing there's going to be a hole because I see that this is going to factor on the top and the x minus 2 is going to cancel. So there's going to be a hole at x equals 2. Let's go look and see. Oh, sure enough, there's a hole at x equals 2. Okay, and it looks like a line because when the top and bottom x minus 2's cancel out, you end up with just a linear function. Right? That part's not quite so important. We're really looking at limits here, but I wanted you to think about that. So what's happening here is as x is approaching, what is it getting closer and closer to? I'm going to change colors here. What is it getting closer and closer to? Well, this is getting closer and closer to 2. Well, what is this getting closer and closer to? Looks like it's getting closer and closer to 3. So that is coming in from the left, okay? From the left. So look at the picture. Is that what's happening? Coming in from the left, we're getting closer to 2 in the x value, and y is getting closer to 3, or f of x is getting closer to 3, and that's exactly what we see right here. Okay, so I'm going to erase some of this. I'm making a mess. All right, so that's what we're trying to say right there, is as x approaches 2 from the left, what is f of x? What is the limit equal to? Okay, so I shouldn't say what is f of x. I should say what is the limit of f of x as x approaches 2 equal to, and it's equal to 3. All right, so let's think about it as it comes from the right side. So we're coming from the right side, so from the right. And in fact, let's go back just a moment. I forgot something. If we're going to fill in this blank number right here, if the first one is 2.9 and the next one is 2.99, then what would the next one be? Hopefully you guessed it, 2.9990. Okay, and then the next one is 2.9999. And so on until you get close, really, really close to, infinitely close to 3. But you're not actually going to get to 3 because 3 is not included. So the point here is to realize that you can get infinitely close, an infinite number of 0.99999s until you get so close to 3 that you're basically there, but you're not actually there. All right, the next one, we're going to look at the coming from the right. So we've got 3.1, and then there's a blank, and then 3.001. So I would say that this one would be 3.0100. Okay, and so we're getting closer and closer from the right. You've got to stop and think about that. Pause the video if you need to. So x is getting closer and closer again to 2, but from the right side. And f of x is getting closer and closer and closer to 3, but from above. So is that what's happening right here? Do you see that? Coming into 2, so we're coming into 2, and we're again approaching 3. But we're never going to actually get there because it doesn't exist at 3. There's a hole. All right, so what happens as f of x approaches from the right? So from the right, y, or f of x, so f of x is also called y, right? Y goes to, or you can say approaches, goes to 3. And as you approach from the left, we're going to say y also goes to 3. So that means that, what does that mean? What did we just say just a moment ago? To evaluate the limit as x approaches 2 of f of x, we have to know that it's the same coming from both sides. Well, is it? They both go to 3, right? They both go to 3. They're not actually touching 3, but they're both approaching it. So then that means that we can say the limit as x approaches 2 of f of x equals 3. So now the next question is evaluate f of 2. Well, think about that. Is there a value at x equals 2? Anywhere? There's not. It does not exist. So in this case, you have to say does not exist. Okay? So now you're going to pause and you are going to go do questions 2 and 3. And I will have little video segments after each one. Okay, question 2. Hopefully this made sense to you. If it did not, I'm going to go over it. You can go back and try it again. Okay, so the first question is the limit as x approaches 2 from the left. So that's how you say that. The limit as x approaches 2 from the left of the function f. So this is the function f right up here, the function f, that's that. What is it equal to? All right, so let's draw on the graph. So I'd like to encourage you to draw right on the graph. So approaching from the left, coming into the place, coming into 2. So another way to think of it is just to go along the x-axis and say, all right, I'm coming in from the left. Well, if I was an ant on the graph, I would be going up this way toward that point, and I would be approaching what value? So I would be approaching 2. Okay, so it approaches 2. All right, let's get rid of all that. Now let's think about it the other way. So now we're approaching from the right. So I'll say that again. The limit as x approaches 2 from the right of the function f of x is what? All right, so now we're coming in from the left. Okay, so that means if we were an ant on this line, we would actually be going up like that. And I would be approaching again the y value of 2. So the answer there is 2. So that means, according to what we said before, the definition of a limit, if we come in from the left and the right and approach the exact same thing, then the limit as x approaches 2 is 2. Okay, so the answer is 2. Now it asks us to find f of 2. So if I plug 2 into this function, I don't know what the equation is, but if I plugged it in, what would I get? Well, I would get does not exist because there is nothing there. There's nothing there. It's empty. Okay, it's a hole. So the answer here would be does not exist. All right, so now you can, the video is going to pause here and allow you to go on to question 3. Okay, so now we're at question 3. And if you had problems with it or not, maybe you'll choose to watch here. All right, so this question says, find the following if no value exists insert D and E, and the graph below is the function of f of x. All right, so let's look at the first question, the limit as x approaches -1 from the left. So remember the little minus sign to the right of it in the superscript there means from the left. Okay, so let's look at the graph and see. So again, we're coming in from the left. If we were an ant on the line, we'd be coming in like this. And we would be approaching this value right here. So we are approaching what y value? Well, it looks like 3. Okay, so it's approaching 3. All right, so let's get rid of all this, and now we'll talk about the next one. The limit as x approaches -1 from the right of the function f of x. Say that to yourself so you've got it. All right, the limit as x approaches -1 from the right of the function f of x is, all right, so we're coming in from the right towards -1. Coming in from the right, coming in for a landing. So we're going to come up the curve. And what are we approaching? Well, once again, we're approaching the value. So what are we approaching coming this way? We're approaching the value 3. Okay, so 3 once again. So now since both of those are the same, we get to say, all right, well, that means the limit as x approaches -1. Notice there is no superscript right there. It just is the limit. The limit as x approaches -1. Because coming from the left and coming from the right are both 3, we get to say that the limit is 3. So now we're going to find f of -1. So if I plug -1 into this function, whatever the equation is, what would I get as an output? Well, there is a point here. So this time we would get to say that the answer is 3 because there's a point. It's not an open hole. Okay, so that's the end of that question, and now we're going to go on with the lecture. Okay, so I am on page 4, at number 4 in the lecture. Use the graph of the function to determine the following. Here's our graph. We don't know what the function is. We weren't given it at all. So take a moment to look at it, and what I see this is a very kind of difficult graph to read, so maybe you want to look at it big, but you'll see that right here is a hole, and right here is a point. So it's solid right there on the bottom half. That's important to answer the question. So what happens to f of x as x approaches from the right? So from the right. So I'm coming in from the right. I'm an ant on the line coming from the right towards approaching -1. So that's what I'm trying to approach. Okay, so I'm getting closer and closer and closer to -1. What is happening? What is it getting closer to? Well, y value is getting closer to -1. So you're going to say the limit as x approaches -1 from the right. Okay, so that's the translation. The limit as x approaches -1 from the right of f of x equals -1. Okay, equals -1. All right, so coming from the left, what happens to f of x as x approaches -1 from the left? So here we are coming in from the left. What is it approaching here? Well, it's approaching what value of y? It's approaching 1 here. Okay, so x approaches -1, but what does y approach? So y is approaching 1. So we're going to say limit as x approaches -1 from the left of f of x equals 1. Notice those are different, and that's important. So now we are supposed to evaluate the limit as x approaches -1. Well, what we're going to have to say here is that it does not exist. Okay, and I know this is the first time we've seen this, so I want to make sure it's really clear. It does not exist, okay, because it is a jump discontinuity, okay? It's a jump discontinuity because these two, I'll put this in red, these are different. That's super important to understand. Okay, I'm going to put a big bubble around it. These are different. All right, so that means the limit does not exist. So now the last thing is evaluate f of -1, just like you would have before you learned limits. Okay, so I'm going to go erase some of this stuff here so we can just think about what is the value of the function when we plug in -1. Where is there a point? So think about that. Where is it? And that is right here. Okay, so because it's solid, there's a solid point right there. So the value of f of -1 is -1. Okay, it's that right there, -1. It's the y value. All right, so that's a closed circle. I'll make sure that's really clear. There's a closed circle at -1, -1. All right, so let's move on to the second graph. All right, this is a parabola with a hole, but check it out. At -3, the point is up there. So that is called removable. Okay, so this is a removable discontinuity. All right, so what happens to f of x as x approaches -3 from the right? Okay, so we're approaching -3 from the right. Okay, so think about if you were an ant on the line, what would you be doing? Well, let me erase that so that I've got a little space here. So I'm coming in from the right towards -3. So what are you approaching? You're approaching, getting closer and closer to the value of 2. Okay, so you're going to say the limit as x approaches -3 from the right of the function is equal to 2. All right. So now, if I'm coming in, what says what happens as x approaches -3 from the left. So now I'm going to be approaching, of course, it's moving down the left, but we're on the function. So we're coming down the function, coming towards -3. And what are we approaching in this direction here? And that is that we're approaching 2 again. Okay, so we're approaching 2. Didn't mean to do that. Okay, so the way we're going to write that is the limit as x approaches -3 from the left of f of x again equals 2. All right, so we're going to evaluate the limit. So when we do this, we have to look at both. Look at both. Are they the same? Are these the same? Okay, so let's make a note of that. Same? Then the limit exists. Okay, so then the limit exists. And the limit is what those two equal. As long as they're the same, that is the limit. All right, so I'm going to erase some of this, and we're going to answer the last question. Evaluate f of -3. Well, where is the point? So where does it actually exist? And that is right here. Okay, so the value of f of -3, what is the y value when x is -3? What is the output? It is 5. Okay, I'm going to just say that's okay. It's okay if the limit as x approaches -3 is different from the actual value. It just means that it's a removable discontinuity of some sort. Okay? All right, so at this point, you're going to work questions 4 and 5. Okay, so looking at question 4, find the limit as x approaches 2 from the left. And so we're going to look at the graph. We're approaching 2, so this is 2 right here, from the left. So we're going to get on the graph like we're an ant on the graph, and we're approaching from the left. What are we approaching? We are approaching 3. So when we say what are we approaching, what we're talking about is the y value. How high up on the graph are we, or low, up and down, are we on the graph? Okay, so we're approaching 3. All right, so if we were coming in from the right, so that's what this means. What is the value of the function? In other words, the output, in other words, the y, when x approaches 2 from the right. Okay, so we're going to approach from the right. And again, we're approaching 3. So now we're supposed to find the limit as x approaches 2. Well, remember, if these are the same, then that means we get to say that the answer is 3. The limit is 3. All right, the last thing we're supposed to do is find f of 2. What is the actual function value at 2? where does it actually exist, if at all? And it does exist. It exists right here. Okay, so that is f of 2, right there where I put the dot. That is, if I plug 2 in, that would be my output value. Okay, and that value is 1. And it's okay that they're different. Okay, that they're different. All right, so now you're going to move on and try question 5. Okay, so another type of problem. Question 5, if you had problems with this, I'll talk you through it. So we've got all sorts of stuff going on here. We've got a removable discontinuity right down here, and we've got a jump discontinuity right here. So this is our function, so we're supposed to find the limit as x approaches -1 from the left. Well, where's -1? -1 is right here, so I'm coming in from the left. So that means I'm going to be coming up the curve like that. And what y value am I approaching? I'm approaching 2. That should say equals. Equals. I don't know why it doesn't. All right, so that is what you do coming from the left. Now what about coming from the right? So I'm on the function value. I'm going to come from the left. What am I approaching in terms of y? Well, I'm approaching -1. All right, so that means the limit as x approaches -1, because these are different, they're different. So that means this, I'm going to do it in red because it's important, does not exist. Does not exist because these are different. Okay? Those are different. I want that in red. All right. So now we want to know, what is the actual function value? Where does it exist? Okay, so make sure you're really clear. Where does it exist when x equals -1? Does it exist? Well, yes, it does, right here. Okay, so f of -1 does actually exist, and it is right there at that point. So what is the value here? Well, it's -3. Okay, so a lot going on that graph. We're going to look at one that has even more here in just a second. All right, so this is more like what you're going to see on a test or homework. So use the graph of the function to determine the following. Okay, so crazy looking function there, but it's a function. So let's look at all of the things happening here. So we have a jump discontinuity here with a value actually up there. So f of -2 is right there. We have a hole, and we have an infinite discontinuity. Okay, so lots of stuff going on here. I'm going to get rid of all that so we can answer all these questions down below. All right, so what is the limit as x approaches, I'm doing A right now, as x approaches -2 from the left? Okay, so -2 is here, right here. So if we're approaching on the function towards -2, we're approaching the value of -1. So that is -1. All right, so I'm just going to keep erasing all my writing because it'll be a mess if well, I'll leave some of it. I'm going to put that line right there. So let's come in from the right because that's what the next question asks right here. So I'm looking at B. Coming in from the right, so x approaches -2 from the right. So we're coming into -2 from the right, and we are approaching 0. Okay, so 0. So now the next question asks, what is the limit as x approaches -2? Well, they're different. They're different. B and C are different. Right? So that means this does not exist. Does not exist if they're different. That's all there is to it. As long as you can just remember that, you've got it, right? All right, so what is f of 2? F of -2. Like pretend you'd never learned limits and I just asked you what f of -2 is. Well, if I went to look at what the value of the function is when I plug in -2, where does it actually exist? It exists right there. Okay, so that right there, let me find a better color here. That is f of -2 right there. So it equals 2. It equals 2. Ooh, I don't know what's happening, but there you go. That's where it equals 2. Okay, so we're just going to say 2. right, so coming back up here to the next one. The limit as x approaches 0 from the left. I'm looking at E. X approaches 0 from the left. Okay, so let me pick a new color. We're coming in from the left towards 0. Okay, and what are we approaching? Well, we're approaching 2. If we come in from the right towards 0, what are we approaching? We're approaching 2. All right, so they are the same, right? These, I need a new color. I want red again. These are the same. So that means the limit as x approaches 0 is 2. Okay, so this has to be the same. Coming from the left, coming from the right, they're both the same answer, and so the limit as x approaches 0 is 2. All right, so what is f of 0? Well, is there any value anywhere where I would plug it in and get an output at 0? There's none. There's a hole. There's no points anywhere at x equals 0. So I'm going to say that this one does not exist. Let's see, what color should I use? Does not exist. All right, so now we're going to try it at 2. So the next one is at 2. So the limit as x approaches 2 from the left. Okay, so the limit as x approaches 2 from the left. I'm running out of colors here. I'm going to go and use orange. All right, so we're coming in from the left towards 2. What am I approaching? Well, I'm approaching 0 right there. All right, so that approaches 0. If I approach from the right, like that, what am I approaching? Well, it's going to go down forever. It's never going to get to it anywhere. It's approaching negative infinity. All right, so now these are different. Right? If it's different, then that means it does not exist. Just like over here, different means it did not exist. All right, so the last one, the limit as x approaches 4 from the left. I'm going to have to repeat some colors here, but as it approaches from the left, we've gotten, what is it approaching? Let's see, it's approaching 4 from the left. Okay, so approaching 4 from the left. What am I getting closer and closer to? Well, it looks like that. Looks like 1. All right, so it looks like it's approaching 1. So now as I approach 4 from the right, is what the next one says, 4 from the right. What am I approaching? Well, I'm approaching the same thing, still 1. Okay, so approaching 4 from the right is 1. So again, these are the same. Those are the same. So we get to say that this is 1. All right, so now if I plugged 4 in, I forgot to do f of 2, shoot. Okay, I'll go back and do that in a second. Let's look at f of 4. So what is f of 4? Let's go find the value, pretending you never even learned limits. I'm just asking you what f of 4 is. It's 1. You see that? Because there's a point there. So it is 1. So those are the same this time, and that's fine. It doesn't, they can be different or the same. All right, let's go find f of 2. F of 2 is, let's see, f of 2 is right here, right there. So that means that f of 2 is just 0. All right, so now you're going to try some of these yourself. Some crazy problems to check out next. So 6, 7, 8, and 9, I will do the same thing I've been doing. You'll have a problem, and then it'll pause and it'll have me working out the problem. And you can skip those if you get them right, or watch them if you want to. Good luck. All right, question 6. This is the function f of x. It's asking for f of negative 1. So sometimes you'll be asked that first, and that's fine. So f of negative 1 is going to be where it actually exists, right? So we've got negative 1 right here going through all these places. And so it's asking you, if the input is negative 1, what is the output? So the output is going to be 2. Right? The output is 2. All right, so what is the limit as x approaches negative 1? This doesn't even ask you for the right and left. It just asks you for the limit itself. Well, it does not exist. Okay, it doesn't exist because it's going to be different. Coming from the left, it's 4. Coming from the right, it's negative 2 point something. And so they're different. And you can tell that just by looking at it at this point, hopefully. Okay, if you don't understand, please come see me. What is the limit as x approaches 0? Well, so let's just look at what it would do if we were approaching 0. As we approach 0, where do we end up? We end up right there. So the answer would just be negative 1. So you basically look for the point on the line. So when there's not an open hole or anything, the limit is the value. So don't let that throw you. Okay, so that was question 6. Go ahead and do question 7. Okay, so question 7 looked something like this. Yours might have looked a little bit different, but using the graph below, state the value of limit as x approaches 2. Okay, so in this case, I can see that, it's different. If I come from the left, it's 3. If I come from the right, it's 1. So that means that the limit does not exist. Okay, so the answer would be does not exist. I'll just highlight that. Okay, does not exist. Okay, you can move on to question 8 if you would like to. There's lots of different ways this question could have been asked, and I can't really talk about all of them, so hopefully that answers your question. If not, please come see me. All right, this is question 8. Yours might have looked very different from mine because there's a lot going on this, and all the problems are different. So let's just look at the ones that I've got here. So f of 6, that means what's the value at 6? So here's 6. I'm going to go up to the graph and find that it's right there, and that's 4. So pretty straightforward. If I said f of 4, what if I said f of 4? What would it be? So you'd come over to 4. Well, it's not there, and it's not there because those are open. It's right there. So it would be 5. Okay. All right, a little bit more. Let's do limit as x approaches 6 from the left. Okay, x approaches 6. X approaches 6 from the left. Well, it's just a point. It's part of the graph. So again, it's 4. As x approaches 7 from the right is this next one right here. X approaches 7 from the right. So 7 is here. It's approaching from the right. What is it approaching? Well, it's approaching 6 right there. So it would be 6. All right, we'll get rid of some of this. As x approaches 6, it doesn't say left or right, so that means it must exist. It must be the same coming from both sides. So right here would be our 6. Is it the same coming from the right or the left? Yes, it's the same. There's no jump or anything. So we can just say the answer there is 4 once again. Okay, so that was question 8. All right, go ahead and answer question 9. Okay, hopefully we ended with an easy one, but if you had any questions, in order for a two-sided limit to exist, which of the following must occur? So I'm not going to read all those to you, but hopefully you found the two one-sided limits must exist and they must be the same. In other words, the limit as x approaches a from the right of f of x, the limit as x approaches a from the left. They have to be equal of whatever the function is. Okay, they must be equal in order for a two-sided limit to exist. Okay, they both have to exist and they have to equal each other. All right, that's it. Thanks for watching all the way to the end. Nice job.